Hello, this is Raphael Shontarai, and I'm back again with another hint on how you tackle your interviews with programming with data structures. Right. So today we're going to be working with sets and how we handle those. This is the first requirement. Describe how you would write a function to find the intersection of two sets. Your solution should not use the inbuilt intersection method, right? Now, without using the inbuilt intersection method, we'll tackle this requirement as follows. We will still use our hash set function in there so that we let our program know that it's a set we're working with, right? So we initiate a variable for the set. Maybe you name it set1 and set2, and then you hash through the set, right? Now, what do we mean by intersection? Intersection, we're talking about what contents of the sets are similar, right, between two sets that we're comparing, right? So, without using the intersection method, we are going to use our variables I and j, right, and use our for loops. We're going to use a loop inside a loop, right? So for I in a particular set, and then we iterate through the whole set, comparing the values of I with those of j in the second loop, right? Iterated as such. And where I is equal to j, we return the value. And therefore, we'll return all the values that are similar or are the same in both the sets. Therefore, we would have retrieved the intersection, right? And then describe how you would write a function to find the union of two sets. Your solution should not use the built-in union method. Continuing likewise, we are going to iterate through the set, right? And through the iteration through the set, we are going to pop the items that are similar and only return one value. For example, in a 1, 2, 3, 4, 5 and a 3, 4, 5, 6, 7, we are going to pop the 3, 4, and 5 from one set, and then we combine it with the remainder. Therefore, we have our set that has from numbers 1 to 8. Right? That's how we tackle that one. And well, the big old performance of both approaches is going to be OR and SWED. Why? Because we are using a loop inside a loop. Right. Well, thank you so much for listening to this. Or maybe before I go, it says here we should highlight 3 test cases that will try to make sure these approaches work. Right. For each, we're going to select let's begin with the intersection. We're going to have 2 sets, set 1 and set B, and set 2 rather. And in set 1 we have 3 numbers, 1, 2, 3, and in set B we have 2 numbers, 3 and 4, right? Those are the sets that we'll be dealing with, and the expected result would be obviously 3 as an intersection, and that would be the expected result. We'd use that as a test, right? And then for a second example here, we'd pick up an empty set as set 1, and set 2 has 2 numbers in it, let's say 4 and 5 in there, and we'd expect to receive 0 as the answer to the intersection, as there is no other number to compare with, right? And another one would be one with similar numbers. Set 1 would be 1 and 2, and set 2 would also have 1 and 2. The expected result would be to return 1 and 2 for the intersection, right? And using the same sets for the union, on the first one, where we said we have 1, 2, 3 as set 1, and 3 and 4 as set 2, we are expecting a result that will just give us 1, 2, 3, 4. Right. Not a repetition of 3. Because the moment we have a repetition of 3, then it's no longer a set, as we are not going to repeat a value within a set. Right. And an empty set and another with 1 and 2, our retrieved result or expected result would be 1 and 2. Right. And for the last one, where we have 2 similar values, we would simply expect to return one of the 2. Meaning in the case of having set 1 being 1 and 2 and set 2 being 1 and 2, we'd return one of those. Therefore, our expected result would be 1 and 2. Thank you so much for watching. You take care. Happy coding.